Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to convert arithmetic and geometric sequences between explicit and recursive forms. How are we learning it? Through the explicit and recursive form part 1 notes and the explicit and recursive form part 1 assignment. When can we use this information? To re-examine issues in your life in different ways so that you can find the most appropriate method of solving the problem. How do you know you learned it? By getting a score of 4 on the explicit and recursive form part 1 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. Next, we'll do our weekly raffle. After that, we'll go over the explicit and recursive form part 1 notes, and then I'll give you time to complete the explicit and recursive form part 1 assignment. Once you've completed your assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the arithmetic and geometric sequences study guide and any incomplete assignments that you may have. Let's take a look now at the explicit and recursive form part 1 notes. The notes begin with the learning goals and success criteria. So let's talk about how we can write an explicit sequence as a pattern. Now, is that always easy to find? No, depending on the term, we don't want to have to keep calculating out. So the easiest way to do this is to write it in explicit form. So the explicit form for an arithmetic sequence is a to the n, meaning the value that we're trying to find, is equal to d, the common difference, times the number that we want, minus 1, plus the first term in the sequence. So an is the term we're trying to find. So for instance, A7 is the 7th term in the sequence. D is the common difference. N is the number of the term that we're trying to find. And A1 is the first term in the sequence. So let's look at an example. We have a pattern here, 2, 4, 6, 8, 10. The explicit form then is AN is equal to D times N minus 1 plus A1. Well, we know D and we know A1. So we know D is 2, that was the common difference, and A1 is 2 because that's the first term in the sequence. Now let's take a look at this one. So we're given that AN is equal to 3 times N minus 1 plus 4, and we want the 5th term. So 3 is our common difference, 4 is our first term, and we want the 5th term. So we're just going to plug 5 in for N. So this becomes A5 is equal to 3 times 5 minus 1 plus 4. Now we're just solve it. So 5 minus 1 is 4. So we're left with 3 times 4 plus 4. Well, 3 times 4 is 12 plus 4 is 16. So the 5th term in that sequence would be 16. So look at another example. Let's try to find the 10th term of this one. That's AN is equal to negative 4 times N minus 1 minus 3. So again, we plug in 10 for n. So this becomes A10 is equal to negative 4 times 10 minus 1 minus 3. Well, 10 minus 1 is 9. So we have negative 4 times 9 minus 3. Well, negative 4 times 9 is negative 36 minus 3. Negative 36 minus 3 is negative 39. So the 5th term in that sequence is negative 39. Now, how can we predict the next term in a sequence? So let's say we know the 20th term. How do we know then what the 21st term would be? So the way this works is we're going to find the next term in the sequence if the previous term is 57, given that AN is equal to AN minus 1 plus 4. So what we're saying is the term we want is equal to the previous term plus 4. So we know the previous term is 57. So we're going to plug that in for this one that represents the previous term. So we have 57 plus 4 is equal to 61. So that's how we use the recursive formula to find the next term. Now let's talk about the explicit form for a geometric sequence. The explicit form looks like this. AN is equal to A1 times R to the n minus 1 power. AN in this case represents the term we are trying to find. For instance, A7 would be the 7th term in the sequence. R represents the common ratio, N represents the number of the term that we're trying to find, and A1 represents the first term in the sequence. So if we're given a pattern here, 3, 6, 12, 24, 48, we go ahead and fill this in. So AN we don't know. We do know A1, and we do know R. So AN is equal to, the first one is 3, and the R value, we're multiplying by 2 each time, so R is 2. So this becomes 3 times 2 to the n minus 1. Now let's take a look at an example. We have AN is equal to 3 times 2 to the n minus 1, and we want the fifth term. So we're going to take that, and we're going to plug 5 in for n. So this is A5 is equal to 3 times 2 to the 5 minus 1 power. Well, we know that 5 minus 1 is 4. So we have 3 times 2 to the 4th power. Well, 2 to the 4th power is 16. Then we multiply that by 3, and we get 48 is our answer. Now let's take a look at the recursive form for a geometric sequence. So that follows this pattern. AN is equal to R times A to the n minus 1. Now, what we're really saying here is the term we're trying to find is equal to the common ratio times the previous term. So if we look at this one, we have AN is equal to 4 times negative 1/2 to the n minus 1. And we want the fourth term. So we start here, and we're going to plug in 4 for n. And we get negative 1/2 to the third power. Well, when we multiply that out, we recognize that negative 1/2 to the third power is equal to negative 1/8. We multiply that by negative 4, and we get positive 1/2. So that would be the term that we're looking at. So let's look at an example here of working with recursive formulas. So we have AN is equal to 3 times A to the n minus 1. And we know that the previous term is 21. So we plug 21 in here. So we get AN is equal to 3 times 21. Well, we know that 3 times 21 is 63. So AN is equal to 63. Let's take a look now at the explicit and recursive form part 1 assignment. The assignment begins with the learning goals and success criteria. If we scroll down, we can see the questions. So we're told that we're going to be converting from explicit to recursive. It says A sub n is equal to 3 times n minus 1 plus 4. So we should notice that the common difference is 3 and A1 is 4. And it tells us that A6 is 2. So remember then that the recursive form is AN equals A1 plus the common difference. So we should end up with 2 plus 3 is equal to AN, which is this one here. So we'll go ahead and mark that as our answer. Here's another one. This time it's a geometric sequence. So we have 4 times 3 to the n minus 1. We should recognize that 3 is the common ratio. So in a recursive form, we have AN is equal to the previous term times the common ratio. So we should have AN is equal to 6 times 3, which is this one here. So that would be our answer. And we'll go ahead and continue to answer all of these until we get to the end of the assignment. Once you get to the end, go ahead and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.